Could there be another Earth out there? This age-old question is closer than ever to an answer with NASA and ESA's new telescopes, which are set to transform our hunt for exoplanets. Get ready for NASA's Habitable World Observatory and the European Space Agency's PLATO. These incredible missions are taking the search for habitable planets to the next level. But wait, there's more. Finding a world that can support life is more than just about having the right temperature. Join us as we launch into the latest discoveries, push the boundaries of space exploration, and reveal the surprising role of magnetic fields in our quest for alien life. NASA's Chandra X-ray Observatory is aiding in the search for life beyond Earth by studying X-ray emissions from nearby stars. This data will guide future telescopes capable of directly imaging planets in habitable zones where liquid water could exist. On June 12, 2024, scientists presented their research on nearby stars at a major astronomy conference, the American Astronomical Society meeting. They had used powerful space telescopes, Chandra and the X-ray multi-mirror Newton, to collect X-ray data from 57 stars, including some known to have planets. Their main focus was how bright, powerful, and variable these X-rays were. This is important because strong X-rays can damage or even destroy the atmospheres of planets orbiting those stars. Scientists have been on the hunt for nearby stars that aren't blasting out X-rays like our Sun. Why, you ask? Planets orbiting these calmer stars might actually have atmospheres that aren't obliterated, making them prime candidates for hosting life. This information is crucial for the next generation of super telescopes that will directly image planets beyond our solar system. The research covers everything from gas giants like Jupiter to more minor planets that could be lighter than Earth. By studying X-ray data, scientists can pinpoint the best stars to search for Earth-like planets that could support life. It's like creating a VIP list for future telescopes to snap some sweet pics of these potential worlds. If you're interested in finding Earth 2.0, be sure to like, share, and subscribe for more cosmic content. Hit that notification bell to stay updated on our quest to find habitable planets. As a thank you, here's a video of a bird playing peekaboo. With our sights set on finding Earth-like planets, NASA is already planning the next big step. Though the James Webb Space Telescope just launched 2 years ago, NASA is already gearing up for its next big adventure with the Habitable Worlds Observatory, or HWO. Think of it as a super Hubble telescope ready to directly image Earth-sized exoplanets orbiting other stars. With a mirror similar in size to James Webb's and ultra-precise optics, HWO will dive deep into the atmospheres of these distant worlds, searching for signs of life. And the best part? It could launch as early as the late 2030s. HWO is still in its early design phases, but some exciting features are already taking shape. This telescope will be stationed at the second Lagrange point, a stable spot located 1.5 million kilometers, about 1 million miles from Earth. This telescope will be designed to directly image small, rocky planets similar to Earth and analyze their atmospheres for potential signs of life. One of HWO's standout tools will be its coronagraph, a device designed to block out the blinding light of stars, allowing us to spot faint objects like nearby exoplanets. But this isn't just any coronagraph. It will be thousands of times more powerful than anything we've seen before. The mirrors in HWO's coronagraph will need to make adjustments smaller than the width of a DNA strand to effectively separate the light from an exoplanet and its host star. Plus, it will use advanced optics that can adjust in real time to minimize stray starlight, making it possible to image Earth-sized planets in their stars' habitable zones. Now, one of the main goals of the Habitable Worlds Observatory is to use a spectrograph to analyze the light from these distant worlds and search for specific chemicals in their atmospheres. Certain gas combinations, like oxygen and methane, could serve as potential biomarkers, hinting at the presence of life on the planet's surface. While the prospect of discovering life beyond Earth is thrilling, astronomers are careful not to overhype potential findings. They want to share their discoveries accurately and avoid disappointing the public if the initial signs of life are something else. That sounds like a good call, but the pursuit of this knowledge is incredibly worthwhile. Finding life beyond Earth, even if it's just simple microbes, would completely transform our understanding of the universe and our place in it. Now, here's a thought. If we find life on another planet, do you think they'll be as obsessed with cat videos as we are? On that note, let's talk about another ambitious space project from the European Space Agency. The European Space Agency is hard at work on a mission called PLATO, which stands for Planetary Transits and Oscillations of Stars. This mission is all about searching for Earth-like planets that orbit stars similar to our Sun. So far, we've discovered over 5,000 exoplanets, but we still haven't found a true twin to our home planet. That could change soon, thanks to PLATO. The main goal of PLATO is to identify Earth-sized planets in the habitable zone of these sun-like stars. Dr. David Brown from the University of Warwick highlights that finding an Earth-Sun equivalent is a top priority. He says, "We want to measure the planet's mass and radius to confirm its existence." Sounds like a big deal, right? But wait, PLATO isn't just a planet hunting machine. It's also a stellar observatory. Scientists hope to learn how planetary systems evolve over time by studying stars and their planets. Dr. Brown explains we're trying to understand planetary systems as whole entities rather than just planet by planet. What makes PLATO cool is its design. It comprises 26 telescopes working together, 2 fast cameras and 24 regular cameras arranged in groups. This setup gives it a wide field of view and helps filter out false positives when searching for exoplanets. We can filter out the mimics we might otherwise see using multiple telescopes, Dr. Brown adds. Plus, it looks pretty cool. PLATO is set to launch in December 2026, way earlier than NASA's Habitable Worlds Observatory, from French Guiana on an Ariane 6 rocket. Are you excited about these new telescopes? Share your thoughts in the comments below. We've all heard about the amazing new telescopes searching for an Earth 2.0, a planet where we could live. But hold on, because finding these habitable planets has become much harder. A recent study from Rice University has broadened our understanding of what makes a planet potentially habitable. Scientists have been looking for planets in the Goldilocks zone, that perfect distance from a star where it's not too hot, not too cold, just right for liquid water. But there's more to finding a habitable planet than just the right temperature. New research emphasizes the vital role of a star's magnetic field in determining a planet's ability to support life. Researchers David Alexander and Anthony Atkinson have proposed that the magnetic interaction between a planet and its host star is crucial. They discovered that only 2 of 1,556 examined exoplanets meet the new criteria for potential habitability, Kepler 23d and Kepler 186f. These Earth-sized planets not only orbit at distances conducive to liquid water, but also possess strong magnetic fields that protect them from harmful stellar activity. Think of it like a force field around a planet, protecting it from all the nasty stuff coming from the star. The study published in the Astrophysical Journal suggests that a planet's magnetic field must be strong enough to shield it from its star's magnetic activity. If a planet orbits too closely, it risks catastrophic atmospheric erosion due to a magnetic connection with its star. Without a strong magnetic field, a planet is a sitting duck for solar storms. And let's face it, no one wants to live on a planet constantly bombarded by space weather. Speaking of magnetic connection, did you know that the northern lights, or aurora borealis, are caused by the interaction between the Earth's magnetic field and particles from the sun? Pretty cool, huh? Now, I know what you're thinking. That's a lot to take in. But don't worry, space enthusiasts. This is just the beginning of the story. We're learning more about the universe every day, and maybe tomorrow we'll find a whole galaxy of Earth-like planets with their force fields ready to welcome us with open arms. And if you're still curious about the challenges of finding habitable planets, our video explores the complexities of this search.